For mobile applications, serialized data is a large and constant chunk of information that you have to pull down from your servers. But did you know that the ordering of the data inside your serialized form can have a huge impact on its resulting size? My name is Colt McCandless, and when it comes to serialized data, it might be worthwhile to kick your object-oriented standards to the curb for something a little more powerful. See, most folks organize their data in memory as objects, full of members and functions and all the other stuff. Serializing arrays of those objects preserves their structure in the resulting data stream. This kind of organization is what we call an array of structs form, or an array of objects or classes or whatever language you want to call it. The gist is that the serialized format mirrors the in-memory object-oriented layout of the data, which is convenient from a programming perspective, but actually ends up bloating your serialized stream. Firstly, consider that in the serialized form, each member value must generally be declared with its property name, meaning that for each instance of your class, every property will have the full property name as well as the value declared in the serialized file. So obviously your file is going to be larger as a result of all these redundant property names just sitting around. Secondly, you need to understand that this is the worst possible data layout for applying compression to your serialized file. Consider gzip compression, which is standard for most HTTP responses. Gzip compresses data by finding duplicate strings in your file as long as they're within a window of 32K characters from each other. So the larger your serialized classes, the further away similar data types are, meaning that there's less duplicating inside of that 32K window, resulting in less compression savings. In general, using the array of structs form creates larger serialized files that don't really compress as well as they should. So what's the solution? The struct of arrays form. Basically, think of struct of arrays as a transpose on your data. Given a list of objects, take all of one property from every element and list them together in their own array, and then do this for each property in the class. For example, make an array for just the width values and a separate array for the height values. The serialized result of this produces simple arrays of similar typed data, and when it comes to serialization, this format has some immediate benefits. Firstly, it removes the redundant property names from the serialized format. Basically, they all get collapsed into a single instance, so already you're going to be producing a smaller serialized file. Secondly, similar data types are now contiguous, meaning that the gzip algorithm is going to have a better shot at finding duplicate matches, since duplicates are now going to be closer together and more likely to exist in the 32K window. And thirdly, organizing your data in this form helps you actually separate out content for different types of compression. For example, if you have an array of 1,000 numbers, chances are gzip isn't going to do much with that information, but it's better for you to apply delta compression to that stream of numbers before throwing it into the serialized file. This is something you really couldn't do in the array of structs form due to the complexities of the object-oriented layout that is inherent there. Now, it's worth pointing out that once you've transposed your data, you can get even better compression and faster serialization by adopting binary serialization formats like protobufs, nanobufs, or flat buffers. These formats produce much smaller files than JSON or XML counterparts. And at the end of the day, that's kind of what you want, right? I mean, different layers of awesome that you can pile on top of each other to create the smoothest app possible. Which is why you should check out the rest of the Android Performance Patterns videos. And don't forget to join the Google Plus community for other insights from other great developers. So keep calm, profile your code, and always remember, perf matters.